So today we are going to talk about cell arrays. So we have looked at uh, several different types of data structures provided by Matlab. Right? We started with some just strings, and we started with tuples, those floating point numbers, and then we talked about vectors and matrices, right? And we used those data structures to actually solve realistic problems, right? For example, how to solve linear systems, how to do matrix multiplications, that kind of thing. Right? But if you think about it, what exactly are matrices and vectors, right? So matrices and vectors are uh, larger containers with smaller containers inside of them, right? A matrix is just a so if a matrix is a 2 row by 2 column, then it's got four smaller containers inside of a matrix, and each of those smaller containers is just a container for a tuple, right? So matrices and vectors are doesn't allow you they do not allow you to actually store different types of data in the same big container, right? So whenever you use a matrix or whenever you use a vector, every small container inside of a matrix or vector must hold the same type of data, right? And this is actually quite restrictive, right? So if you are purely dealing with just a linear algebra or purely dealing with mathematical problems, this might be enough, but in order to actually solve realistic real-world problems, this kind of a container or this kind of composite container is highly restrictive, right? Sometimes we would like to actually to store different types of data. For example, we would like to combine the name of a person, which is a string, together with a a integer, which is used to store his age, together with his or her blood pressures, which could be integers or uh, floating point numbers or whatever thing, right? Or heights, weights, those might be floating point numbers. And for every person, we would like to actually group all those different data types into like one composite data structure, that kind of thing, right? And Matlab actually provides uh, two different types of this kind of composite data structures that allows to store heterogeneous type of data, right? One is called cell array, and the other one is called structure or Matlab struct, right? And today we're going to look at the cell array, right? And how it can be actually used for storing heterogeneous type of data, right? So a cell array is still just a bigger container, a composite container. It's a large container, and inside it can have multiple smaller containers, and each of those smaller containers can actually store different types of data. Right? It doesn't have to be all tuples like a matrix or vector. Right? It can be different types of data. So let's try to create a new script, and then this time um, we're gonna write our code in this particular script, right? And then uh, let's give it some kind of a comment. Let's call it a cell array operations, right? So inside of this particular script, we're gonna look at how we can actually use cell arrays. Cell arrays, it's whenever you think about cell arrays, you think about a matrix, except that all the different elements inside of that matrix can be anything, right? It can be strings, numbers, or it can be another cell array, or it can be a matrix, or it can be anything, right? It doesn't have to be doubles anymore, right? So the first thing we're gonna do is to look at how to create. Let's save it and give it a name. Let's just call it cell operations, right? When we did the vectors, we did the vector operations, right? And then we did the matrix operations. This time it's gonna call it cell operations. Let's just save it, right? And then the first thing we're gonna sort of try out is how do we actually create cell arrays, right? Uh, create cell arrays. Let's uh, let's um, let's look at a very simple example first. Let me see if I can find a very simple example, right? So the first thing we're going to notice is that when we create any kind of matrix or vectors, we're using square brackets to actually group together all the elements, right? On the right hand side, we usually use a square bracket to actually concatenate together all the different components of a matrix or vector, right? But for cell array, we have to sort of change the square bracket to this kind of a curly bracket, right? And then inside of this thing, inside of this curly bracket, we put together a bunch of elements, all those components, right? Suppose we want to put together um, two rows and three columns, right? And on the first row, we're going to put strings, say one, the string one, and then the string two, and then string three, right? That's going to be the first row, right? And then we want to do the second row. So how do we actually switch to a different row? Don't use comma anymore. Use semicolon, right? So if you want to separate different columns of the same row, you use comma. This is identical to matrix, right? But if you want to sort of separate different rows, you want to use the semicolon. So when we did the matrix thing, then when we construct the matrices, we also use the same kind of convention, right? Comma and semicolon. Comma separate different columns. Semicolon separate different rows. And then for on second row, we want to store all numbers. Say 1, 2, 3, right? And that's going to give us a cell array. And let's run it. Let's run it. Right. So C is going to be a 2 by 3 cell array. And the cell is in blue because it's a link. It's a link to a help page about what cell actually is, right? So if you click on it, it's gonna give you a pop-up window explaining what exactly is cell. But if you actually look at what's actually inside of the C, you're gonna see different types of data mixed together, right? So on the first row, you're gonna see strings 1, 2, 3, right? And then on the second row, you're gonna see 1, 2, 3, the numbers 1, 2, 3. So all those different types of data are being mixed together, stored inside of one thing that's called a C, right? C is a cell array, right? And every different elements inside of a cell array is called a cell. So a cell is just a wrapper. You can think of a cell as a wrapper around different types of data. So if you put different types of data into a cell, and then you can use that cell inside of another cell array, right? So different elements inside of the cell array is called a cell. So this is a cell. This string is a cell. No, this string is stored inside of a cell. This string is stored inside a cell. This string is also stored inside a cell. This number is stored inside a cell. This number is also stored inside a cell, right? And then we have a 2 by 3 cell array, which means that every element inside this array is a cell, right? But a cell is more general than a specific data type, and it can be used to store different kinds of data, right? It doesn't have to be just a double or string. So that's C, right? So let's look at some slightly more complicated examples, right? Let's look at some slightly more complicated examples from our textbook. Right? This is an example from our textbook, um, maybe it's a good idea for me to actually give the page number. Right? The page number is page 141, right? Page 141 of Engineer's Guide to Matlab. Right? It's got a separate paragraph or a separate section that's called cell arrays, and it gives some quite complicated examples, right? We're not going to do all of them. We're not going to do all the examples, but let's just look at the section that's going to create the cell array, right? The first thing that the textbook does is to actually create 4 different types of arrays, 4 different types of arrays of uh, different data types, basically. So A equals to, it's going to be 1, 3 by 2, right? So A is going to be a matrix filled with ones, right? And then it's going to be 3 rows, 2 columns, right? And then B is going to be equal to what? B is going to equal to magic 3. We haven't actually looked at the magic function before, right? Magic is going to create some kind of matrix that's going to, if you are curious about what magic function actually is, help magic, right? Um, so magic is going to create a n by n matrix, so it's a square matrix, right? And then it's constructed from the integers 1 through n to the power 2 n squared, right? With equal row, column, and diagonal sums. So if you sum together all the rows, columns, and diagonals, you're gonna get the same sum basically. Produce a valid magic square for n larger than except for. So it's just generating a special kind of matrix. It's what exactly is the content of this matrix is not really of our concern. So let's just and then the C matrix is gonna be what? The C matrix is gonna be created using char. Again, we haven't actually looked at the char function, right? We haven't looked at char function yet. So if we do help char, it's a way for you to concatenate the strings. It's a function for you to actually concatenate the strings together. So the manual page is a little bit long, but later on we're going to look at what's actually the effect. The effect is actually quite straightforward. It's not really that difficult to understand. It converts array x of non-negative integer codes, but that's not exactly what we're using. So when C is a cell array, when str is a string array, it converts each element of str into a row of the character array, right? So that's how we are going to use it. Use string to convert back. So let's give it a string array, right? Let's give it a string array. So how do we actually give it a string array? Pressure, right? Pressure, temperature, and then displacement. Right. So it's a string array composed of 3 strings, right? And then maybe let's do a screen dump so we can see what's actually the output of C, right? And then D is going to be a complex matrix, a matrix with complex numbers, right? So if you don't feel comfortable about complex numbers, they are just a special kind of number used in various. It has useful applications in different disciplines. So 6 plus. How do we actually create a complex number? Say that. So that's the real part, right? That's the real part. And then how do we actually write the imaginary part? Say 7j, right? So that's the imaginary part. The imaginary unit is j basically, right? You can use either I or j, but in engineering it seems that j is used more widely, right? And but in mathematics I seems to be used more widely. So that's gonna give you a complex number. The real part is 6. The imaginary part is 7. Right? And then let's give it a real number also, right? So now we have created 1, 2, 3, 4, 4 different matrices, right? Let's just run it and see what's gonna happen, right? So A is just a matrix composed of ones. B is another matrix composed of all the so-called magic numbers, right? If you sum up all the rows and sum up all the different columns, then they are gonna give you the same sum. So 8 plus 1 is 9, 9 plus 6, that's 15, right? So 8 plus 3, that's 11, 11 plus 4 is also 15. So if you add up all the different columns or different rows and also diagonals, then it's gonna give you 15 basically. And then what's actually created by C, right? So what exactly is inside of C, right? C is created by the char function, and we are giving it a sequence of strings. So what char is going to return is basically just a concatenation of all those different strings in different rows. Basically, the first word, the first string is going to appear as the first row. The second string is going to appear as the second row, and then the third string is going to appear as the third row, right? And then all the strings are going to have different number of characters, different number of letters, right? Right. So what we have, what char is gonna do is that it's gonna sort of fill up the strings with less number of letters, with fewer number of letters, with just a space, so that every row is gonna have exactly the same number of characters, right? So it's gonna give you a trailing space for words that's kind of too short, right? So every word is gonna be extended to the same length as the last string, basically, right? And then it's gonna use white space to fill up the empty spaces. And then that's D, right? So now let's create a cell array using this these four different things, right? Let's call it CEL, right? That's gonna be our cell array. So do you still remember how do we actually do the concatenation? We have to use the curly brackets, right? We have to use the curly brackets. And then suppose we have like four different things, right? A, B, C, D, four different things. Suppose we want to arrange these four different things into like two rows and two columns. So how are we going to do that, right? So we're going to put A and B on the same row, right? And then we switch to the second row, and then put C and D on the second row, right? Let's do a screen dump. Let's suppress the screen dump from these four lines, and then let's just run it. So cell, so the output is gonna be just look like it's just gonna look like that. It's not gonna display the content of all the different cells, right? We got like four different cells, right? It's not displaying the content of the cells, but it's just telling you the type. It's telling you that A is a 3 by 2 double, B is a 3 by 3 double, right? And then C is a 3 by 12 character, 3 rows, 12 characters, basically, right? That's 3 rows, 12 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's exactly 12 characters, right? So it's a 3 by 12 character. And then the last one is a 1 by 2 double, right? It's called double, but it's actually complex numbers, right? But the real and imaginary parts are doubles. Right? So it's basically just telling you the information or the data type of those different cells, right? But it's not gonna display the content of the different cells. Right? So now let's look. Suppose you would like to actually look at the content of the different cells. How do you actually do that? Right? How do you actually do it? It's called a cell disp. We can use a function that's called a cell disp, and then we can just put a CEL as the input, right? Suppose we suppress the output from this line, and then let's just run it again, right? And now it's gonna display the content of all the different cells, right? So cell 11, you have to pay attention to the syntax here. It's curly brackets, right? You can also use parentheses here, just like you index into a matrix, right? But you have to be careful, right? It's not gonna give you a syntax error, but it's gonna give you a completely different output. We're gonna look at that kind of thing in a little bit, right? So that's gonna print out the content of every cell. See, that's the content of every cell. It's not just telling you the information, right? Right. So that's how we actually create a cell array and how do we actually display the cell array's content, right? If you just do a default screen dump, it's not gonna display the content. It's just gonna display the structure or the type information of each of the different cells. Right. And that's a slightly more complicated example um, for creating cell arrays, right? But let's still look at some even more complicated example, right? Um, um, Now let's look at how we can actually suppose we have a composite data structure that we need a composite data structure that allows us to store strings, matrices, vectors, complex numbers, and sort of a sort of almost everything, right? And then suppose we wanna to store one cell array in another cell array, for example. So can we actually do that, right? Go to nesting one cell array inside another. Can we actually do that? Right? Can we actually do that? So suppose we have medical records for different people, right? For different people, um, and then these records are gonna be uh, for multiple people. So for every row of the records are gonna be for just one person, and then we have multiple rows, so for multiple person, right? So let's see if we can actually try to create a records for medical records, and then the first row and all columns, right? So here we're actually indexing into something that's called a records, which doesn't exist yet, but we don't see records here, right? In the workspace we don't see records here, right? But by doing this kind of thing, looks like we are actually indexing into a non-existent records uh, matrix or vector or cell array or whatever container, right? But it's okay. It's okay because Matlab is going to automatically create the records, this particular container, for us once we actually try to index into it, and then give a valid assignment. So now let's try to give it a valid assignment. So what's going to be the assignment that we're going to put into records? The first row of records, right? We're gonna assign a cell array to it, right? Curly brackets. So we're gonna assign a cell array to it, right? So how do we actually assign a cell array to the first row of records? The first thing we're gonna do is a string that's gonna be the patient's name, Kelly, say, right? And then separated by comma. So it means that we're switching to the second element of this particular cell array, of the first row of this particular cell array, right? So it's a comma. And then the second number is going to be age 49. That's an integer, right? And then um, let's try to construct another thing. You see, I'm putting another curly brackets inside of the outside of the curly brackets. So it's a nested cell area now, right? So what's going to be inside of this nested cell area? We're going to put um, the weight, the height, and then uh, maybe maybe the weight. Uh, the weight, let's give it like a 58, right? And then um, the heartbeat, right? The heart rate, and then we are gonna give it some kind of pressure, the blood pressure, and the blood pressure has like two numbers, right? It's always got like high blood pressure, lower blood pressure. It's got two numbers. I don't really know what's why we have like two different blood pressure, but one of them is like always larger than the other one, 72, right? So that's the thing that we're actually creating, though. That's the thing that we're actually creating. So it's a cell array, right? It's a cell array. So the first row of records is going to be a cell array. And then what's going to be the different columns of the different cell array, right? It's going to be a string, the first column, a number, right? And then another cell array for the last column, right? And then this cell array is going to have a number, another number, and then a vector, right? So let's run this line of code and see what's going to happen, right? But let's what might be a good thing to do. Let's just comment out this line and then run the whole thing. So now we have records, right? So inside of this workspace, we're seeing that records is a 1 by 3 cell. It's a 1 row, 3 column cell, right? Records. The first element is Kelly. It's displaying the name, right? And then the age. But for the last element, which itself is also another cell, it's just telling us what's actually the type, right? And then the dimension. It's a 1 by 3 cell. Why it's 1 by 3? It's 1 row, right? But it's 3 columns. The first column, the second column, and then the last column is a vector, right? A vector of two numbers. Um, so that's one of the ways. That's one of the ways of nesting a cell array inside another cell array, right? But let's try to sort of do things in a slightly different way, right? So sometimes this kind of nesting may become awkward, right? If you don't exactly understand what's actually the meaning of all those different numbers, it could give you some confusions, right? So let's do things in a slightly different way, right? Or let's call it let's construct something that's called vital signs. Right? Vital signs, maybe vital signs. Let's do a camel case, right? Let's construct this cell array first, this inner cell array first, and then put it into a vital signs container, right? Let's get it like a 60, right? And then 98.4, and then 105, 75. Right? That's the vital signs for a particular person, right? And then let's do a records. Second row or the columns is gonna equal to what? It's gonna equal to, let's give it a different name. Let's call it Adam. Right? And then it's a age of 52, for example, right? And then for the vital signs of Adam, let's just put vital signs. Right. So now records actually is gonna so at this line, records doesn't really have a second row, right? But when Matlab actually sees this line, it's gonna actually create the second row inside of records automatically, right? So it looks like you are indexing into a non-existent row, but for Matlab this is okay because it's gonna create the second row at the same time uh, when it's actually doing this kind of assignment. So let's run it, right? So now records is gonna be 2 rows, 3 columns, right? And then um, for the first row it's Kitty, information for Kitty, and then for the second row it's information for Adam, right? So here we have created like 2 different rows, but using slightly different syntax, right? So here you just directly writing the cell array inside of another cell array, but here you construct a cell array first, and then just use that cell array as one of those elements inside of a bigger cell array, right? So that's sort of nesting, right? That's sort of nesting. But you can also try to actually create each individual cell inside of a cell array, right? You create them one at a time. So how do we actually do that, right? How do we actually do that? So how do we actually do that, right? Create one cell at a time. Suppose we would like to create a cell array that's called A, right? Capital A, and then it's got like 3 rows and 3 columns, right? And we can try to actually create each element one at a time, right? So let's first try to actually create A11 first, right? So how do we actually index into a cell array, right? The same way as we actually index into a matrix, right? But if we actually do things in this particular way, then on the right hand side, what do we have to assign to this particular element has to be a cell, right? What does it mean? It has to be a cell. It means that we have to give a curly bracket, we have to put whatever content we want to put into it, surrounding it with this curly brackets. That's creating a cell basically, right? And inside of these curly brackets, we can put anything. Suppose we put a matrix, right? Put 1, 4, 3, and then 0, 5, 8, and then 7, 2, 9, right? So that's gonna be A11, and A11 is gonna be a cell, right? Because we have this kind of curly brackets outside of the content. So if we run it, let's get rid of this. Oh, I I was reusing A, right? Because I have used A before. So let me give it another name. Let's just call it A1 or something, right? So A1 is gonna be a what? It's gonna be a 1 by 1 cell, right? And then the first element inside of it is gonna be a 3 by 3 double, right? So if we want to do a cell disp A1, then we're gonna see the matrix that we just entered, right? But if we actually do a cell disp, you're gonna see something that's kind of strange, right? So even though we are actually indexing into the cell array A1 using this kind of parenthesis, 1 1, like we index into a matrix, but when we do a cell display, cell disp, it's gonna use curly brackets, right? So for matrices, it's not gonna take curly brackets as a sort of a group for the indexes, right? But for cell array, it can use both. You can use either parentheses or curly brackets to actually group all the indexes. But they have very distinct meanings. They have very different meanings, right? So here you are using parentheses, right? If you are using parentheses to index into a cell array, which means what? Which means you are extracting the cell at this particular index. And what's actually inside of that cell is irrelevant. You don't care about what's actually inside of that cell. All you want to do is to actually sort of, for this particular assignment, all you want to do is to actually to put this particular cell in this particular location, right? 1 1 location, right? But if you actually try to index into a cell array with something else, for example, suppose index using curly brackets. So suppose you do A1 curly bracket 1 1. If you do that, then what's gonna happen, right? Then what's gonna happen? So this parenthesis is gonna allow you to extract the cell at this particular location, right? But this curly bracket is going to allow you to extract the content inside of that cell at this particular location, right? So whatever content is stored in that particular cell, 1 1, right? It's going to try to actually retrieve it, right? So if we do an assignment, right, then what do we have to assign to this particular thing on the right hand side, on the left hand side, must be the content that has to go into that 1 1 cell, right? What's going to be the content, right? What's going to be the content? That's still using the same matrix, right? That's still using the same matrix. Let's copy it and then paste it, right? But is that going to be the thing that you desire? Is that the what we wanted? It's not what we wanted, right? What we wanted is to actually put this matrix as the content into this particular cell, right? But here, by putting a curly brackets around this particular matrix, we are explicitly constructing a cell, right? So what we have been doing is to actually assign this particular cell as the content of this particular cell. Do you see what's actually happening here? So if I really want the matrix to be the content instead of a cell to be the content, then I have to get rid of the outside curly brackets on the right hand side, right? And so if we do that, let's still run this code. And then do a cell disp. I'm gonna get exactly the same thing as before, right? The same thing, right? That's the same output. Right? But suppose I actually add a curly brackets around it. And then let's run it. And then let's do a cell disp A1. Then it's gonna do something that looks really strange, right? It's gonna not displaying A1 1 anymore, right? It's gonna display A1 1, 1. You have a second level of curly brackets. Do you see what's actually happening here? Right. So it means what? It means that Matlab has to go down one more level in order to actually retrieve the content, which is the matrix. Right. That's what that's the effect of actually putting a curly brackets here. Right. So A1 1 1. So if you do this thing, that's gonna give you a cell, right? But if you do this thing, it's gonna give you the content of the cell. And then if you assign this thing to that content, then that content is going to become a cell again, right? And then if you want to actually retrieve the content of this particular cell, you have to go one more level down in order to actually retrieve that content, right? And that's not exactly what we wanted. So let's get rid of this particular curly brackets. It's not going to give you a syntax error. So syntactically, it's still correct, but it's not just what you wanted, right? Okay. And then let's try to assign some more. Uh, let's do 1 2, right? So first row, second column, it's gonna equal to some string and Smith, right? And then again so this is actually retrieving the cell, right? So I must so on the right hand side I must give it a cell. So that's why I have a curly brackets around it, right? But if I actually change it to curly brackets, then I want to give it a string on the right hand side, right? Because the content has to be a string. And then a 2 1 no A1 2 1 is going to equal to what? It's going to equal to um, let's again I have to give it a cell, right? Let's just use like one complex number, 7i, right? And then A1 2 2, for example, 2 2. I have to give it another cell, so let's give it a vector. So minus pi to a stride of 4, pi over 4 to pi, right? That's a vector wrapped inside a cell. And then A1 3 by 3 3 row 3 column, that has to be another cell, right? Here I just want to give a number, but I have to wrap the number inside of a parenthesis to make it a cell first, right? So now let's run this code, and then let's see what's gonna happen, right? One of the things that I may have noticed is that I didn't actually assign specific values to every element inside of this A1 cell array, right? But what's going to happen? What's going to happen if I missed some of the cells, some of the cells inside of this cell array, right? So A1 is now 3 by 3, but that's supposed to be 9 elements, right? But all I did was like 1, 2, 3, 4, 5 assignments. So some of the elements, some of the cells inside of the cell array are going to be some kind of unspecified values, right? But let's just look at what those unspecified values are, right? Let's do a cell disp again. Right. So this A1, so 1 1, it's got a matrix, right? 2 1, that's a complex number, but 3 1 is showing you empty matrix. Looks like an empty matrix, right? It's a pair of square brackets and then nothing in it, right? And then 1 2 and Smith, that's the string, right? And then 2 2, that's kind of the vector that goes from minus pi to pi with a stride of pi over 4. And then empty, nothing again, and then nothing again, and then the last one 3 3 is a number 5, right? So if you want to sort of look at what exactly is A1 2 3, that's an empty cell, a cell with nothing in it, but it's still a cell, right? But suppose I do a curly brackets, I want to retrieve the content, it's nothing, right? So this in Matlab, this kind of empty brackets means it's just an empty data type, right? So suppose I do a class ns, it's giving you a double, but it's still an empty bracket, right? There's nothing in it. looks like it's gonna be an empty matrix that can be used for storing doubles, right? So that's those unassigned elements, what they are gonna appear inside of Matlab. Right? So um, there there are multiple ways for doing this kind of assignment. You have already seen that, right? So this is one of the ways, right? This is another way, depending upon how you actually index into this particular cell array, right? Using parentheses or using curly brackets, you have to give it the corresponding thing on the right hand side, right? So if you are indexing into the cell array using curly brackets, you have to give on the right hand side, you have to give the content, right? But if you are indexing into a cell array using this kind of smooth parentheses, on the right hand side you have to give it a cell. So how do you actually create a cell? You wrap whatever content inside of a pair of curly brackets, right? So that's one of the very important distinctions when we actually use cell arrays. About those unassigned cells or unassigned elements, the matrices and vectors actually behave. Matrices and cell arrays actually behaves quite differently, right? So let's do a very short experiment. Let's give a 2, 4, 6, right? So that's a is just a vector, a row vector with like 3 numbers in it. Let's assign to 2, 1. The second row, first column, right? Let's assign to number 8 to it, right? And then as soon as we do that, we are gonna create some unassigned elements inside of this A matrix, right? Because for the second row, you have like the first column has a value, but for the second and the third columns of the second row, we haven't actually done any assignment yet. But what's gonna be the Matlab's default behavior, right? So let's look at it. It's gonna fill up. It's gonna fill up those 2 different columns that we haven't actually put in any numbers in there with zeros, right? So the default value that's going to be used for filling up the unassigned elements in a matrix are going to be zeros, right? But for cell arrays, it's a kind of different behavior, right? We have seen that. So suppose let's just to uh, let's just create a 2, 4, 6. Let's create the array C with like 3 elements, 1 row, right? And that's a 1 by 3 cell array with 3 elements, right? And then C, let's 2, 1, right? So we have to give it we have to give it a cell, right? We have to do that, right? And then it's gonna be empty matrices, right? So the default behavior or default value for those unassigned elements inside of a cell array are gonna be different from zeros. It's not zero. It's definitely not zero, right? It's something that's called an empty matrix, right? So if you want to use a cell array as a matrix, you have to understand this kind of difference in terms of behavior, right? For those unassigned values. For matrices, it's gonna replace all the unassigned values with zeros, but for cell arrays, it's gonna do this kind of thing, right? It's gonna give you empty matrices. Sometimes we may want to sort of pre-allocate the memory for storing a cell array, right? So um, sometimes the cell array could be quite large, right? And if we ask Matlab to actually create those different cells inside of the cell array on the fly, Matlab will have to actually allocate memories, right? And those kind of memory allocation operations are kind of expensive. It takes lots of clock cycles in order to actually allocate those memories, right? And if we want to do this kind of thing very, very often, our code is going to be slow, right? So here we're actually doing this kind of thing. If we are sort of trying to create the cell on the fly, one cell at a time, it's going to be kind of expensive because Matlab has to constantly adjust its memory allocation for this particular one cell array, right? So if we know the dimension of the cell array, we could pre-allocate the memory for the cell array at the beginning, and then we just fill up all the content or the different elements of that particular cell array. So how do we actually pre-allocate, right? Pre-allocating memory for serial array. We use the command that's called cell, and then we give it a dimension, say 25 rows, 50 columns, that kind of thing, right? So if we run it, so then C is going to be what? C is going to be 25 by 50 cell. This many cells. It's going to have 25 rows, 50 columns, and each of the element inside of C is going to be a cell, right? And there's also another way. Right? There's also another way, because suppose we know it's already 25 rows and 50 columns. Then what we can do is to actually the equivalent way is to actually index into 25th row and 50th column, right? So here we are actually using this kind of a curly brackets index, right? It's called a content indexing. If we're using this kind of content indexing, we have to give it a content. So the content we give it is this kind of empty matrix, right? So if we run this code, it's still going to give us a C that's 25 by 50 cells. But every element inside of it are going to be filled up with this kind of empty thing, right? Empty matrix thing. It looks like an empty matrix, right? If it helps you to remember what. So sometimes if you decide to actually use a really big cell, sometimes it could be, right. Suppose you are loading something from a huge database, right? It's going to be useful, and it's going to be more efficient if you actually pre-allocate the memory for the cell array, right? And then now let's look at so all those things are kind of related to create cell arrays, right? So suppose now we have the way to create cell arrays. Let's look at how to actually do concatenation of cell arrays. How do we actually do concatenations, right? Suppose we create like 4 different cell arrays, and then we let's create like just 3 cell arrays, right? 3 cell arrays, and then let's try to actually concatenate them together. See, so C1 equals to AUG August, September. That's the first row, and then the second row is going to be 10. The string 10, it's not a number 10, and then string 17, right? That's the second row. And then the third row, let's give it some integers. We haven't actually created the integers in Matlab yet, right? Every number that we typed is going to be automatically double, right? So if we want an integer specifically, we have to use some kind of function, uint. Suppose we want a 16-bit int to represent the year. So that's going to give us a int, a 16-bit int, right? And then let's do another uint 16 2014, right? So that's going to be our first cell arrays called C1, right? And then let's try to create two more C2 is going to be December, January, February. That's the first row, and then 31, string 31, 2, string 10, and then that's the second row. And then the third row, let's use a few more ints. Uint 16, 2007, uint 16, 2008, and then uint 16, 2008, right? And then curly brackets again, right? That's C2, and then C3 is going to be what? C3 is going to be June 23, and then uint 16, 2002, right? And then that's it. That's C1, C2, and C3. Right. And now let's try to concatenate C1, C2, and C3 into C4. That's C4. So how are we going to do the concatenation, right? Let's use curly brackets, and then C1, comma, or space, doesn't matter, C2 and C3. And then let's see what's going to happen, right? Hold down the control key and press enter. So C4 is going to be 1 by 3 cell array. So C4 is going to be a cell array, right? It's a curly brackets. And then inside of this C4, we're going to have 3 different cells, right? It's a 1 by 3 cell array. It's 1 row, 3 columns, right? So it's basically a cell vector, right? Cell vector. It's got 3 elements inside of it. The first element is going to be 3 by 2 cell, 3 by 2 cell, 3 rows, 2 columns, right? 3 rows, 2 columns. That's C1 basically. And then C2 is going to be 3 rows and 3 columns, right? 3 by 3 cell, 3 rows, 3 columns. And then C3 is going to be 3 by 1, right? 3 rows, 1 column. Right? So that's C4. Right? And then let's look at another way. This time we're going to use this kind of square brackets. That's C5, right? And let's still give C1, C2, and C3. Right? And then hold down the control key and then press enter. Let's see what's actually going to be C5, right? Obviously, it's very different from C4 now, right? Because C4 looks like that, but C5 looks like this kind of thing. Do you see the difference now? Do you see the difference now? Right? So C1 is what? C1 is what? C1 is actually the 3 row 2 column, right? 3 row 2 column. So this part is C1 actually. This part. So August, September 10, 17. August, September 10, 17. 2004, 2014. This part, the first 2 columns of C5 is actually coming from C1, right? And then C2 has like a 1, 2, 3, 3 columns, right? 3 columns, 3 rows, 3 columns. So this part of the C5 is actually coming from C2, and then the last part is actually coming from C3, right? So that's actually a very different cell array, right? C5 is still a cell array, but what Matlab has done is that it has unwrapped all the contents of C1, C2, and C3, right? And then put those contents into a new cell array in this kind of order: C1 first, C2 next, and then C3 last, right? 2 different ways of concatenation, giving you 2 different kinds of results. For C4, it's just still keeping all the wraps around all those individual cells, right? And then it's just using those different cell arrays as elements of this bigger cell array C4. But here C5, by using this kind of square brackets, Matlab is going to do some kind of unwrapping for you. It's going to unwrap all the different cells inside of those individual component cell arrays, and then recombine them into a new cell array. That's called C5, right? So that's different ways of concatenation, right? That's called a content concatenation. And then let's call it cell concatenation. Cell array concatenation. Right. So that's concatenation that we have to be quite careful about. We have to be careful about, right? So this video might be too long, so let's stop here. We haven't actually finished talking about operations on cell arrays yet, but we'll leave it for the next video. And in the next video, we're going to look at some more complicated ways for indexing, for how do we actually indexing into a cell array, which might be nested, right? So multiple levels of indexing, and then how do we actually use cell arrays with functions, different kinds of functions, and what's going to be the effect of applying those functions onto cell arrays, right? And then how do we actually use cell arrays together with function handles, that kind of thing.